All right, guys, so this lesson is about sig figs. So some of you guys have learned sig figs already, some of you haven't, so just pay quick attention and we'll see how quickly we can do this. So sig figs in science always are reflective of how accurate a measurement can be. Okay, so there's only a certain amount of accuracy you can get with certain measurement devices depending on how accurate the measurement device is. Okay, so that uncertainty is reflected in the sig figs. So sig figs is short for significant figures, by the way. So let's take a look at this graduated cylinder. The markings are the measurements that we can be sure about. So if we read this graduated cylinder, and remember we read from the bottom of this curved meniscus right here, okay? So right now we're sure about the 50 and 51, 52. So 52 are certain. Okay, now we're going to add one estimated digit so that the meniscus is between 52 and 53, and this is where we make an estimation. I would say it's like 70% to the 53 line, so that's 0.7. Okay, so you basically like mark it down in like gradations of 10 and make that last estimation. Okay, so we'll get more information on how to make measurements in the next lesson. But this is what we mean about sig figs. So now we know this measurement device is only accurate to 3 significant figures. Okay, the first 2 are certain, the last is estimated. So all measurements will contain one estimated digit at the end. So again, that's why there's uncertainty, because no measurement instrument is ever going to be infinitely accurate. Okay, for example, here's 2 scales. The one on the right is going to be way more accurate to more decimal places than the one on the left. So we're going to have different numbers of sig figs coming from each measurement device. So when it comes to counting sig figs, there's a few rules to learn. First, any number that is not a 0 always counts. So, for example, this measurement here has how many sig figs? 4. Okay, next up, the kinds of zeros. There are 3 kinds of zeros. The first are leading zeros. These are numbers that start with a 0 and they never, ever, 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 ever count. Okay? For example, these first 2 zeros right here don't count. So this measurement has 3 sig figs. Okay? It's just the 4, the 8, and the 6 because these leading zeros don't count. Next kind of zero is a captive zero. And like the name implies, if you're captive, you're kind of like trapped. And these zeros always count, and they're zeros that are trapped between 2 other actual numbers. Okay, so it doesn't matter where they are in relation to a decimal point or anything. If the 0 is within the measurement anywhere, it counts. Okay, and that's a captive zero. So this one is going to be 4 sig figs. The last kind of zero is trailing. Okay, that's we're kind of making a pattern here. We looked at the beginning, the middle, now these are the zeros at the end. Now these are only significant if the number contains a decimal point anywhere in the number. Okay, so for example, this guy has 2 leading zeros on the end, and this number does have a decimal. So that means we have 4 sig figs in this measurement. Okay, so let's practice this a little bit. Take a look at these examples. Oh, I'm sorry, yes, in exact numbers. So exact numbers are like counted numbers. So let's say I have 32 students in the classroom. That number, there's no estimation, right? I don't have to guess if there is a fraction of a person. There's not a random leg hanging out of my classroom. So counted numbers are always exact, and counted numbers are infinitely significant, okay? Just like conversions, like going from 1 inch. 1 inch is exactly 2.54 centimeters. So we would say these numbers have infinite significance. Okay, so again, all counted numbers are also infinite. Okay, that's going to come in later. Okay, so let's practice. So how many sig figs in the following? Take a look here. Make your guess. There you go. This has 5 sig figs. These 0 in the middle, they count their captive. This 0 on the end counts because it has a decimal point in the number. This was a trailing 0, but it counts because there's a decimal. Next up, what do you think? 4 sig figs. Okay, this one has a trailing 0 as well with a decimal. Trailing zeros with decimals count. Next up, that's a comma, just so you know, it's a comma. How many do you think? There are 5 sig figs in this number, so the first 4 numbers count. I'm sorry, the first 5 numbers count. These 2 zeros count because they're captive, and then the 0 on the end, that is a trailing 0, and there is no decimal, so this does not count. Next up, so there's a funky rule. Anytime that anything is written in scientific notation, the numbers out front count as being significant. So this one has 3 significant figures. Next up, what do you guys think? This one has 2 sig figs. These numbers at the beginning, these are leading zeros. Leading zeros never count. So it's just these 5 and the 4. And how about this one? Again, those are commas. What do you think? 2 sig figs is correct, and that's because you've got no decimal. So these were trailing zeros with no decimal. Trailing zeros with no decimal never count. So that's how you count sig figs. Now, when we do math with sig figs, there's 2 rules you need to know. One of the rules is for multiplying and dividing. That's the first rule that we're going to learn. So here's the word definition. It's probably going to make more sense when you see the example, but the number of sig figs in the answer equals the number of sig figs in the least precise measurement in the calculation. So let's look at this example here, okay? We've got this number with 3 sig figs being multiplied by this number with 2 sig figs. So between 3 or 2 sig figs, the smaller number of sig figs is 2. So when you do your calculation in the calculator, this times this, you get 12.76. But we can only report this out for 2 sig figs. So we look at the first 2 numbers, 1, 2, and then we round. So because there's a 7 following this 2, we rounded it to 13. Okay, so now we have 2 sig figs. So 13 is your final answer. So let's take a look at our practice, okay? So here's our practice calculation, okay? There are 3 sig figs in this number. There are 2 sig figs in this number. Your calculator says that, so what should the answer be reported as? 23 is the answer. That's because we can only have 2 sig figs in our final answer. So we take the 2 and the 2, we look next to it and we say, oh, we got to round that up. And so now we have 23. Next up, we have 4 sig figs here and 3 sig figs here. So when we do this math, we can only have 3 sig figs in our final answer. So this is what your calculator says. Rounding this to 3 sig figs, you're going to get that. Okay? So here's this again. If your calculator says that, what should the answer be? There you go. So this one we could only have 1 sig fig because these were leading zeros. So rounding this to 1 sig fig, we keep the 4. Next to the 4 is a 7, so we round that up to a 5. Next one. Calculator tells you this. We can only have, well, let's see. What do you think it should be? We have 2 sig figs here and 2 sig figs here. So how do we round our answer to 2 sig figs? You end up looking, so we keep the 2, we're going to keep the 3, and then we look next to the 3 and there's a 6. So we're going to have to round this up. So rounding this 3 up is becoming 240, okay? A lot of people make mistakes here and they'll just write 24, okay? Guys, 240 and 24 are absolutely different numbers. You absolutely should keep your placeholding zeros. So this 0 on the end here, remember, it's trailing, there's no decimal, so it doesn't count. Okay, so this number has 2 sig figs. So keep those placeholding zeros in mind. Use them when you need to. As long as there's no decimal, they won't count. Okay, take a look at that. This is what your calculator tells you. What should the answer be? Okay, this one again, we had 3 sig figs in our smaller answer. I'm sorry, our smaller measurement. So we had to round this to 3 sig figs. So we kept the 5, the 8, the 7. Looking next to the 7, there's a 2, so we can round that down to a 0. Remember that 0 is not counting. It's not significant because there's no decimal, but we need it to hold the place. So this reads 5,870 instead of 587. Okay, next up. Calculator reads this. What should it be? There you go. Okay, so again, we have 4 sig figs here, 3 sig figs there. So reporting this out to 3 sig figs, we had to round up that 5 to a 6. So that was what you guys just saw. That was multiplying and dividing. Okay, multiplying and dividing, that was the rule. The only other rule you have to remember is for adding and subtraction. Okay, addition and subtraction, you throw the sig figs out the window. Now what we're looking at is decimal places. Okay, that's the only thing we're counting. So take a look at this. We have one decimal place here, 3 decimal places here. We can only keep the least precise measurement. So right now, we can only keep the measurement with 1 decimal place in it. So our final answer can only have 1 decimal place. Okay, so I know this says sig figs. Literally, you can ignore the fact that you can ignore sig figs altogether. We're just counting decimals for addition and subtraction. Okay, so this one's pretty easy. So take a look here. That's your calculation. Your calculator says this. We have 2 decimals here, 1 decimal place there. So our answer can only have 1 decimal place. Okay, here's another one. 1 decimal place, 2 decimal places. Calculator says that. So we have to round it to this. Okay, so what would you do? With this one, your calculator says this. What are you going to report it as? There you go. Okay, so 2 decimal places, 3 decimal places. We can only keep 2 decimal places. How about this one? We've got that. Your calculator says this. What are you going to report? There you go. So we have 1 decimal place and 3. So we can only keep 1 decimal place. There's your answer. And again, the reason we're doing this rule is because it's addition and subtraction. Okay? That's the rule for addition and subtraction. Again, here we go. There's that. Your calculator tells you this. What's it going to be? There you go. So we have 1 decimal place here, 2 decimal places there. So we have to round our answer to 1 decimal place. I think this is the last one. We've got 3 here, 3 here. We do our math and your calculator tells you this. Now what do you think you should answer? There you go. So this is an interesting one because when you do the math, your calculator isn't going to add the extra 0 for the significant figures. You have to remember to do that yourself because there's 3 decimal places here and 3 decimal places here. So you should have 3 in your answer. Okay, so that's everything with sig figs. It gets easier the more you practice with it, so get to work on your homework, and if you have questions, come to class with your questions and we'll work on it together.